Hello everyone, welcome to my channel. In the last video, we saw the basics of Azure AI Foundry. In this video, I actually wanted to have an elaborate RAG demonstration, but I thought about it and felt that it will make more sense for me to do something simple before we go into full RAG. We are still going to use RAG. We are still going to run our Python code, so our custom Python code. We are still going to have an external data source, but it wouldn't be as elaborate as the next video. So rather than having a three video series for this AI, it's going to be four because I want to create an intermediate one before going deep into the more comprehensive ones. So let me share my screen first. Along the way, I'll shed more light on what RAG really is. So I'm hopeful that you can see my screen right now. You can see the Azure portal. Yeah, so what we are going to be doing is similar to what we did in the last video, just that this time around, we are going to be incorporating RAG into it through an external source. In the last video, we were using just the learnings from the LLM. So just how the LLM was trained, that was what we are using to get our responses. But in this video, the whole concept of RAG is that there are some responses that needs to be fine-tuned, customized to a particular user, probably in the form of connecting your system, either your LLM or external from your LLM, to your database, to um, any kind of data source that would ensure that the kind of information that it will be returning will be more complete and more accurate. So RAG is not something that is particular to just Azure. It's an AI framework. It cuts across various AI offerings. So before I start with the explanation, let me just start my hub and my project. So I'm creating a hub now as we did in the last video. Let me call this do not think I need to go to the other pages. So review and create. So I'm creating the hub now. We already did this in the last video, so I don't need to explain all of this. So the AI Foundry is what used to be known as AI Studio previously. And there was a time many of the AI services it was scattered around our job, but now everything is now centralized into a single place. So with AI Foundry, you have all you need to do around AI in a central location. So this is loading. While this is coming up, as I said earlier on, RAG is not particular to Azure. It's something um that cuts across artificial intelligence as it were. To be more specific, um, we want to, it actually stands for retrieval augmented generation, which I think I've mentioned earlier on, and it enhances the capability of our LLM, in this case, will be using GPT-4 by allowing our GPT to access and incorporate information from external knowledge bases. And this external knowledge base, as I said, it can be a database, it can be some documents, it can be a static or dynamic document, it can be a web page, it can be a data repository, it can basically be anything that is capable of hosting information. So it basically bridges the gap between general knowledge that the LLM is giving to us and what it has been trained to give to us and what we specifically want and what is more up to date. Because if we're connecting into a database, that database is probably being updated in real time. Yeah, so it's something that is key when it comes to artificial intelligence. So our hub is created already. So let's just create our project. So I'll be launching my AI Foundry by clicking here. So as I click on that, you can see the URL is now ai.azure.com. It's different from the hub where we have portal.azure.com. So it took me to ai.azure.com. So over here, we want to create our projects. So I'm clicking on create a new project. So I'll call this PRJ Family. Okay. Okay. So I can create up the project now. Yeah, so while the project is being created, so as I was saying, that RAG basically um bridges the gap between what the LLM has been trained for and what we really want it to give to us. Yeah, yeah, so this is done. Our project has been created. So what we need to do now is we want to create a base model. So I'll come over to models and endpoints from the left navigation. I'll click on this. Then I'll under model deployment, come here, click base model. You can see there are two options there. I want us to see it. Base model and fine-tuned model. So we are going with the base model because we want to create a foundational model for what we are working on. So we are looking at GPT-4. GPT-4 mini. Yeah, let me confirm that. Uh, yeah, so many models here. So I think let me use GPT-4. GPT-4 mini. I think I'll be good with it. So there are so many, depends on what you want to do. There are different categories of models here. You can pick the one you want. Then also the deployment options. So some models have specific deployment option they support. Then we also have by the organization that are in charge of the model that developed it. You can see DeepSeek, it has been added here, which is great. Okay, so GPT-4 mini is what I want to use. Yeah, so I'm deploying it now. So the code for this, okay, when we get there, I will let you know. I'll be sharing my GitHub page so that you have access to the Python code that I'll be using in this demonstration. Yeah, so we have this. We can open our playground. I'm here to explain what we really want to do. I'm just going through the flow. So very soon I will explain what we are actually doing. Okay, so this is our usual playground. We can add context here. We are near I said I will find information. Um, we can add data, we can add parameters, and we can enter our query here. Okay, so what I want to do is I want to go over to data and indexes. I want to add a search index. Before I do that, let me explain something. So for us to demonstrate our RAG, I have a data source, and the data source is just a very simple data source. This is it here. We have four different categories of information. We can see OB invited three friends for a party. Atiku arrived before Tinubu and Panchacho arrived after Atiku, who arrived first. We have four different logical questions over here. Okay, so this is just a sample. Like in our next video, we are going to be connecting to a real database that has a lot of data. Um, but we have this now. So we now want to create an AI model that have that has access to this information. I have this in PDF format. So it has access to it in PDF and is going to be able to connect to our LLM independently from outside of Azure, and it will be making deduction based on this information. So that is our problem statement, if I can use that word. So I click on data files, I come over to new data. I want to add a search index. So I come over here, I go to upload files and folders because we want to upload a file and folder. Okay, so I'll click on upload file or folder. Okay, so that's my AI data source. So I would click next. I'll give it a name. Let me call it what can I call it? Let me call it frankly your data source. Um no, let me just call it AI data source. Your data source. Your data source. Then I quit. Yeah, so this it has been created because it's a PDF, can't preview. But this has been created. Okay. So what I will do now is let's see. I'll go back. I'll click on indexes. I want to create a search index. So I'll choose where my data source is. In my own case, it's a data in AI Foundry. You can see there are so many options here. That's what makes RAG very powerful. So I'll click on data in Azure AI Foundry. I'll select this. This was what I just um uploaded. Then I'll click on next. Yeah. So over here, what we want to do now is if I click on the AI search service, nothing is populated. So it means we need to create one. So we need to click on create a new AI search resource. I'm going to explain some of these things very soon, but I'm trying to make sure the video is not very long. That's why I'm just trying to move fast. But there are a lot of explanation that comes with this. So I'll call this search service frankly okay. I'll change the pricing tier from standard to free because this is just a demo. Then I'll review and create. Hopefully it's going to work. Yeah, validation is successful. So now we can create this search service. I'm hopeful that this video will not be more than 30 minutes, but the way I am going, it's very likely that it exceeds 30 minutes because we have not even started to write our code. And we are still going to connect from my computer, my local machine to Azure. Yeah, deployment is successful. We can go to our resource now. Now, what I will do is I'll come back here because it has been created. I'll come back here and I would come to this drop down. I'll click on connect other Azure AI search resource because I already created one and this is it. So I'll click to add connection and ensure you have API key over here. Add connection. Yeah, so now if I should click on this arrow, I'll see my search service listed. I'll click on it. Then I'll click on next. I'm still going to explain the whole concept of vector databases is very core when it comes to our discussion on RAG. You'll be hearing something like approximate nearest neighbor. The algorithm that RAG usually use that is central to RAG. We'll be looking at all that while this deployment is ongoing. I'll click on next. There's a deployment we are going to do that will take about 5 minutes. So I'll use that 5 minutes as it is propagating to do some explanations. And I'll click on next again. And see it requires an embedding model. And this embedding model is what we are going to be discussing about. So let me create the vector index now. So I'm clicking to create the vector index now. Yeah, so while this is being done, while this is being done, yeah, while this is being done, let me just explain a few things about RAG. You might ask that uh, why do we need to go through all these AI search index, all these vector, setting up a vector index and the likes when we can just upload a document. I mean, if you visit ChatGPT now, there's an option there that allows you to upload a document and um you can query based on the content of the document. You can send queries based on the content of the document. That is a type of RAG, but we are not using it to its full capability. So you might ask, why are we going through all these search index and vector databases and the likes? And I documented some fundamental reasons why we are doing that. And I think the most obvious one is the limitation of just uploading a document is that I think the first one I would say is the limitation of just uploading a document. You know, when you upload a document, it's usually limited to just some categories of data. But with RAG, you can see the several options that we had. I mean, we can essentially connect it to a full database, to a real-time database, unlike when you are just uploading static files. And aside that also, different categories of data, different services on Azure, it's more integrated to this environment. Okay. So that's one core reason why we are going through all that. But that is not all. Another very important reason do why we go through um all of this is what I said earlier on vector databases. If you do not want to add your database to the model, or you do not want to add your context, some of these terms that I'm using, they might sound strange, but if you go on the internet and try to read more about them, you would get more perspective on what I'm trying to explain. So, as I said earlier on, vector databases, there are a couple of algorithms that it uses, and it is particularly helpful you are when you are querying your LLM for an information that is not that that there's no clear answer to it. So in that case, the algorithm that you have chosen in your vector database will try to determine what is most similar to what you are seeing, especially when the user is not sure of what he is not presenting his query in a very concise manner. In that case, such an algorithm comes in handy. But all these they are not optimized when you are not using the search index that we are trying to use. I mean, I think I have a graphical illustration for that. So let me scroll down and I'll show you something very interesting while this is going. Okay, so have a look at this. You can see this table. It looks a lot mathematical, and this is why people say that artificial intelligence um is very, if you are good in mathematics, um you will have an advantage when it comes to understanding how large language model work. But the good thing about Azure is that even if you are not good in mathematics, you can still be a great AI engineer. But if you really want to try to understand how Azure is really working, how the models are really working internally in Azure, then all this will come in handy. You can see there's a question here. Take a look at this graph. You can see that there are different positions to these queries, and query 2, query 3 are closest to the question, and query 4 is far apart. And based on this particular graph will determine the query that will be sent over to the large language model for processing. And in our next video, in our next video, yeah, you are going to be seeing this in actual practice, in actual demo, because for this video, for this particular tutorial, we are not really doing a lot of this. We are not using a database. So let me check to see if my deployment is completed. Oh, I'm in another folder. I'm in another browser rather. Wow. I was explaining something in another browser. Okay, so this was what I was explaining on. So what I was speaking about. Yeah, this is the graph, the question and the query, determining what should be sent to the large language model. Yeah. Then when we talk about vector databases, tokens and embeddings, so each of these queries are being converted into tokens, and the token are now um, turned into embeddings, and this is what we use to create our vector database. Okay, so let me check if my deployment is complete. Okay, still in step 1. This usually take approximately 10 to 15 minutes. It has gone to step 2 now. So we still have some minutes for some more explanations about RAG. Yeah, so I said number 1, I spoke about the volume and the support for different category of data. Then I also spoke about how using a search index allow you to um, it allow you to limit the amount of context that you'll be adding to your prompt. So it's kind of like separates more like separation of duties. Instead of doing it while for each question there are contexts involved, that should be separate, not at prompt time. Okay. So, and also the scalability is also one issue as well. Then the search capabilities is easier to retrieve and manage larger data sets. The structured data management, it's more structured and organized. Yeah, so adding data directly is basically limited. Yeah, so we're in the last stage now. We're in the last stage. You can see registering index. That is going. Yeah. So this was the PDF that we added. This is the data in there. Obi invited 3 friends for a party. Article arrived before Tinubu, and Kwansha arrived after Article. Who arrived first for the party? Then there are 8 pieces of pencil on the table before Kwame took one. Um, Kwame took one, Kofi took two, blah blah blah. So we have all that. Okay. So we're in step 3, registering, and it is finally done. And one thing I didn't say is that if you want to check out what is happening, we can go to the machine learning portal by clicking on job details here to take us to ml.azure.com, and we can track our search, the embeddings and the chunks, how they are divided. So what is really happening is this diagram that we have here, where I spoke about the embeddings and the tokens. This is what's really happening. So we are every word in that search index that we spoke about, it's being converted into a token. The sentences are chopped into different words, and those words are now converted into embeddings, uh, which are actually just numbers. So if I should go to the machine learning portal, yeah, this is the machine learning portal. You can see the embeddings here. And you can see everything was successful. Okay. And you can see some values over here as well. Yeah, so we are good. So let's go to our next step. Let me check what we should do next. We really need to move very fast now. Yeah, so we've created the search index, we've uploaded our PDF file. And what we want to do now is we are going to add our index to our model. So our GPT-4, we are going to be adding our index to it. So I'll go to my playground. I'll go to my playground. I just discovered that I even made a mistake in our data source. So instead of the play data there, it's meant to be party. What we have here is meant to be party, but I am not going to modify it. RAG to, I want to see when I run the model, I want to see if our LLM will be intelligent enough to see what is similar and make that inference. Yeah, I use party. Yeah, I use playdate, which was a typo, an error. But let's continue and we'll see. So, yeah, we have our playground here. We'll come to add your own data. But instead of uploading a file, what we want to do is a project index. So we are not adding a data source, a static data source. We want to add a project index, and which is this. So I click on this and it is being added, which is great. Yeah, yeah, so we are good for now. So what I'll be doing is so it's time for our Python now. It's time for our Python. So I will probably create another video on the Python aspect because I want to move very, very fast for the coding aspect. So basically, when it comes to AI, we are going to be doing a lot of Python programming, and what we use is so Python, we have our static Python programs, and we also have Python Notebook. Python Notebook is an interactive kind of Python code, and we use Jupyter for it. You can install Jupyter on your computer. Jupyter is free. Just Google Jupyter. Just Google Python Jupyter, and the spelling is a little bit different from the regular Jupyter. Instead of I, use Y. So I already have Jupyter installed in my computer. If you don't have it, at the end of this video, I'll be adding a link on how you can install Jupyter. But I already have it installed, so I'll be opening my terminal. I'll be opening my Git bash, my terminal. Just give me a moment. Let me launch my Git bash. Even though this is a video, I just have a feeling that people might not be understanding what I'm saying, but I will just continue. Uh, yeah, so I'm on Git Bash now. I'll be sharing my screen. So let me stop sharing first. I'll stop sharing my browser. Okay. So I'll stop sharing my browser. I'm going to share my Git Bash now. Okay. So I'm hopeful you can see my Git Bash. So what we want to do is very simple. As I said earlier on, there are different categories um of Python codes, and it also depends on the environment you are running it. But you can convert Python notebook to the regular Python, and instead of using Jupyter, you can also use Visual Studio Code. But I just prefer to use Jupyter. I feel it gives a lesser code, a lesser load to my system, because if I want to use Visual Studio Code, I will have to add a lot of extension. I will have to add some extensions to my Visual Studio Code, but with Jupyter is direct on my browser, so it's a lot easier for me. So what I will do is so basically the first thing you need to, before you install Jupyter, you need to have Python installed, because I mean it's for Python notebook. So to check if you have Python installed, you do um Python version, Python version. Yeah, and you can see I have Python installed, and you also need pip as well. You also need to have pip installed, pip version. I have pip installed, hopefully as well. And in case after you've installed Jupyter, you have a message that it is not in paths, that it is not in your current paths. I will also add um, a link on how you can modify that. So you can see I also have pip installed. So what we need to do now is, assuming I wanted to install Jupyter, I would have just went with pip install Jupyter, and I will install Jupyter, but I already have it installed, so I just need to enter Jupyter Notebook. Yeah, so this is basically what I'll use to run Jupyter. So there are three things I'll be including in the code that I will be sending. One, how to install and set up Jupyter. One, then how to add Jupyter to your current paths. Then thirdly, how you can yeah, how you can convert the command, how you can convert Python notebook to normal Python, to regular Python. Okay, so I've clicked on enter now. We are launching Jupyter. The good thing is that I have the codes. I think it was just before we started this, I worked on the code for this project, and I would just copy it and paste it or something. I will only change the environment variables. I wrote the code myself, so I'll be adding it to my GitHub, to one of my GitHub account, so that you can work on it in collaboration with Microsoft documentation. So we are launching Jupyter now. Yeah, so now let me stop sharing and share my browser, because Jupyter will work on my browser. Where's my browser. Okay. Okay, so we have this. If you've not worked with an interactive programming language before, this might be a little bit strange for you, but if you follow through, you'll be good. Okay. So what I want to do is this was what I worked on. I'll be opening this. It's loading, it's loading. Okay. So this is the program. So how did I get this code? So I went to from the Azure portal over here, our chat playground. You see a button for view code. You just need to go over here, click on it. Then you have an managed identity or enter ID authentication or key authentication. I'm using key, so I choose key. You can see we have different languages here. You have JSON, Python, C Sharp, and the likes. Go. And you also have the SDK you want to use, Azure Open AI or Azure AI Inference SDK. Okay. So I'm working with Python. That's why we have this. In our fourth video, we are going to be working with C Sharp. We are going to be using C Sharp. But right now we are using Python. Okay. So I'll come over here because there are a couple of things I want to change. And don't bother trying to copy this. I already deleted the OpenAI key and the likes that this was used for. So what I'll be doing now is um oh from here, yes, from here, we are going to be copying the endpoint URL. What we have here, we'll be replacing it. So this endpoint URL, copied it, come over here, endpoint URL will be replaced with this. Then GPT-4 mini is fine. Then open AI API key. Where's our open AI API key? So we have to get that. So let me go to I want to get our open AI API key now. So let's open this project. Okay, let me even just get it directly from here. Let me close this instead of just going. Um, so I'll paste the key here. Yeah. Then the search endpoint. The search endpoint. Uh, this is the service endpoint. It's different from the search endpoint. So I don't want to open it from here. Let me go here. This. Yeah, this is the search endpoint. Copy this. Yeah, then the search key. Uh, search key. Come to keys. Copy the primary key. Copy the primary key and we paste it here. So some of the things that I do not explain about Jupyter, I'll probably explain them in my GitHub repository because I'm trying to beat time and this video is already getting too long. I don't like long videos. Okay, so let me see what else do we need to replace. So let me scroll down. Yeah, we need to replace this endpoint. Yeah, this needs to change. So let's go back um to the playground and view code. I'll scroll down. Key authentication. I will scroll down. Yeah, I need to copy this. The endpoint or for the embedding dependency. Yeah, okay. So another thing is the key. I need to paste this as well. Okay. Yeah, so I think we are good. I think we are good. Yeah, so I think we are good. Um, okay, so no, the index name also needs to change. Index name. So I'll be running the program now. I'll be running the program soon. Let me close this. Okay, so I'll be running the program now. I just want to be sure that everything is in place. So let me run it. So the way we run it is you will just come over here and click run this cell. So I'll be running this cell. As I said, it's interactive. Delete all this. Yeah, so it's running. So what we want to do now is I want to invoke um I'll go over here. Um I want to invoke a statement, a query. So based on what we um based on what we fed into the large language model now, um we now want to get responses from it. And how do we do that? I'll be pasting this. Want to know who arrived at the party first. This party. Remember that this is what we fed into it. That Obi invited three people to the party. Atiku arrived before Tinubu and Kwashiorkor arrived after Atiku. So who arrived first for the party? So the answer should be, so let's run the model and we'll see the response that we'll get. We're running this cell now. Yeah, so you can see who arrived at the party, we are getting it in a JSON format, and the content we are looking for at Obi's particular article arrived, but we're making article the first to arrive for the play date. So the response is article. So our AI model is saying it is article that was the first. And if we should look at what we have here, um, is article the first? Article arrived before Tinubu. So article arrived first before Tinubu. And Kwansha Shaw arrived after article. So who arrived first? So it's definitely article. So our model um made a lot of sense. So let's assume now that instead of entering who arrived first, let me enter something for the second case study. There were 8 pieces of pencil. How many pieces of pencil were on the table after Kwame? So let's take this. So I'll go over here again. So let me just copy this. Or I can just type it actually. So how many pieces of pencils were on the plate after Kwame and Kofi took some? That's what we're asking our LLM model. So I will run this. You can see it is interactive. So we ran the first one, we are running another cell again. So let me run it. You can see the response. Where do we get the response from? It's from content. Initially, there were 8 pieces of pencil on the table. After Kwame took 1 pencil and Kofi took 2 pencils, the total number of pencils left on the table can be calculated as follows. Blah, blah, blah. Equals to 5 pieces of pencils remain. Therefore, there were 5 pieces of pencils on the plates after Kwame and Kofi took some. Yeah, so you can see the response that we are getting. So I think this is just a very, very simple demonstration of RAG. So this is actually RAG in action. We had an external data source and we are doing multiple things here. This particular program is external to Azure. So up here, you can see we are connecting using endpoint URL, deployment name, OpenAI API key, and search endpoint, search key, and the like. So it's outside of Azure. And we are sending a request, and we are getting a JSON response back. So any external application that we have, we can filter down to the response object. So where we have the response key value pair, we can come over to content and we would filter into this response. So I think this makes sense. So I hope it makes sense. So in this video, I just wanted us to have a simple example. So this is very core before we start, before the next video, because the next video, we are going to be using a real database, and we're also going to be using a vector database, a vector index, something that we are working with. We have a sample file with vector indexing. Although there's still vector indexing here, but we are not the ones, we are not kind of like in charge of it. It's the automated one that we are working with. Yeah, so let me just be sure I touched on everything I plan to touch on. Yeah, so one thing that is very core is I try to explain the differences between adding data from directly and using the search index and the likes. And I said structured data management, advanced search capabilities, and scalability are some of the key things that we are looking at. And I spoke about RAG. I said that RAG um, um, comprised of three major stages, and which is what the acronym is made of. Retrieval. So when you pose a query, the RAG system first retrieves relevant information from an external base, and that is where that graph that I showed you come in handy. So the process of retrieving relevant information is where that cosine graph come in. So it will retrieve that information based on similarity. Then there's an augmentation aspect whereby the retrieved information is then combined with the user query and fed into the LLM. So retrieval and augmentation, the kind of the flow is together. So after that is done, then after it has gotten what is similar, then it sends it to the LLM. Then this augmented input provides the LLM with the necessary context to generate a more accurate and relevant response before the generation. The generation is where the LLM will use both its pre-existing knowledge and the retrieved knowledge to generate a response that is grounded in factual data. So you can read about all this, but what we basically did in this video was we add GPT-4 as our base LLM model. Then we now connected our LLM model with a search index using Azure AI search. We connected it to an external file that is adding that is acting like a knowledge base, an external knowledge base. Then outside of it, we now created a Python program that programmatically connected to our LLM deployment on Azure, and it also sends queries as requests, and we got response back based on that request. So I think that makes sense. Thank you very much. The next video will be very, very comprehensive, very, very comprehensive. So if you are yet to understand this video and the first video, then don't even bother coming to the next video because that one is um more tilted to a real life scenario.